My name's John,
And I'm Adam.
and we're presenting a proposal on the performance analysis of a waste heat recovery thermoelectric generation system for automotive application for the ME4622 undergraduate seminar. Our proposal presentation is laid out with the literature survey, the improvement proposal, and the references.
The first two studies we looked at the first study was high performance thermoelectric materials, progress and their applications. We looked at the effect of different nanostructures on thermoelectric materials. The second study was a numerical study on thermoelectric hydraulic performance of a thermoelectric power generation with a plate fin heat exchanger with longitudinal vortex generators, also abbreviated as LVGs.
For the third study, we looked at an application of a DC-DC boost converter with a maximum power point tracking for low power thermoelectric generators. And this used the DC-DC boost converter to reduce the electronic equipment required.
The fourth and fifth studies we looked at were design and optimization of automotive thermoelectric generators for maximum fuel efficiency improvement and heat transfer enhancement of a modularized thermoelectric power generator for passenger vehicles.
For study 6, we looked at the theoretical analysis on a segmented annual thermoelectric generator that used a segmented design with different sections composed of two materials. For study 7, we looked at the effect of its TEG performance on a waste heat recovery of automobiles using magnesium oxide and zinc oxide nanofluid as coolants.
Eighth and ninth studies we looked at were a study of different heat exchange technologies' influence on the performance of thermoelectric generation systems, and a compact automotive thermoelectric generator with embedded heat pipes for thermal control.
For the 10th study, it was a comprehensive review of the thermoelectric technology, including materials, applications, modeling, and performance improvement.
Overall, from the other studies, we can conclude that the more research that has been done into thermoelectric materials can lead to more efficient and optimized TEG systems in the future, as the ability of the material to handle thermoelectric energy increases. The auxiliary equipment, such as the LVGs, the DC boost converters, and other more efficient heat exchangers, leave a possibility for more efficient systems in the future. And then the nanofluids that were tested as a coolant showed performance increases in power output, conversion efficiency, and voltage overall in every system.
As far as aspects that weren't considered by the original study, module design changes of any type were not considered. The only thing they considered were increasing the number of modules. As well, different coolants that were used in the onboard and external cooling systems weren't considered. Considering the importance of delta T to the total output of power, any change of that delta T would be of great interest in improving the original study. And as other studies we reviewed have shown, using magnesium oxide nanofluid coolant shows significant increases in performance.
So in looking at how to improve the original study's results, you can always just test different types of thermoelectric materials in the TEG system that they constructed in pursuit of a more efficient system, as the other studies looked at a lot of different thermoelectric materials for different systems. For example, silicon carbide has shown to increase the performance of thermoelectric generation systems, so we could try something like that. We could also test the effects of other additional auxiliary equipment, similar to the reference studies, is like the LVG and the DC-DC boost converter, as well as other equipment can create a larger temperature difference, as a larger temperature difference increases the overall efficiency of a TEG system. Also, we're looking for the results of the other tests that were not conducted. So because they only conducted a couple tests with their apparatus called the Warrior, the sample size is very limited, but they could just run a couple more tests of different load types and load capacity to observe the changes.
And these are the references.